Hello students, how are you? I hope all of you are good. So today I am going to discuss integration by partial fraction method. Basically this partial fraction method is used to integrate the proper rational functions. Used to integrate proper rational functions. Proper rational functions. Now the doubt is, what is meant by this proper rational functions? To understand this proper rational function, first we should know what is meant by a rational function. What is meant by rational function? Now what? Rational function. Rational function means any function is of the form px divides qx, where qx is not equal to 0 and both px and qx should be a polynomials, then such type of functions are known as rational functions. Rational functions means any functions is of the form px divides qx, where qx is not equal to 0 and both of these two px and qx should be a polynomials. Such type of functions are known as rational functions. Now what is meant by this proper rational functions? Now what? Second point, proper rational functions. Proper rational functions. Proper rational functions means the rational functions in which degree of the polynomial px less than degree of the polynomial qx. Such type of rational functions are known as proper rational functions. The rational functions in which the degree of the polynomial px is less than the degree of the polynomial qx, such type of rational functions are known as proper rational functions. And if suppose degree of the polynomial px is greater than or equal to degree of the polynomial qx, such type of rational functions are known as improper rational functions. What is the next point? Improper rational functions. Improper rational functions. So improper rational functions means degree of the polynomial px is greater than or equal to degree of the polynomial qx. So such type of rational functions are known as improper rational functions. Such type of rational functions are known as improper rational functions. Now the doubt is, what is meant by this degree of the polynomial? Now what? Degree of the polynomial. Degree of the polynomial means, now the third point is what? Degree of polynomial. Degree of a polynomial. So degree of the polynomial means highest power of the variable involved in the polynomial is called as degree of the polynomial. I hope all of you understanding. Degree of the polynomial means highest power of the variable. Highest power of variable. Highest power of variable involved in the polynomial is called as what? Degree of the polynomial is called as degree of the polynomial. So let us consider some examples to understand this degree of the polynomials. So now the first example is, see here, find the degree of the polynomials. Find the degree of the polynomials. First one, x square plus 2x plus 1. See here, basically here exist three terms. So first term, the power of the variable is 2. In second term, power of the variable is 1. And in third term, power of the variable is 0. It means among these three powers, 2 is the highest value. Therefore, degree of this given polynomial, let us consider this is equal to px, and degree of this px is equals to what? 2. So let us consider one more example. Suppose qx is another polynomial, and qx is given by x cube minus 2x plus 1. Here also there exist totally three terms. In the first term, power of the variable is 3. In the second term, power of the variable is 1. And in the third term, power of the variable is 0. Among all these three quantities, 3 is the highest value. Therefore, degree of this polynomial is. Therefore, degree of this polynomial qx, degree of the polynomial qx is equals to what? 3. I hope all of you understood the degree of the polynomial. Now let us consider some rational functions, and we need to observe whether which of the examples or which of the functions are proper rational functions and which are improper rational functions. Let us consider some examples. So now third example is one of the rational function, and we need to identify whether it is proper or improper. So now the first one is x plus 1 divides x square minus 2x plus 1. So observe here, here the given rational function is x plus 1 divides x square minus 2x plus 1. So observe here, degree of the px, degree of px means what? The polynomial in the numerator. The highest power of the variable in this px is 1, therefore its degree is 1. And same thing, the degree of the polynomial qx, the degree of the polynomial qx, that is what? The polynomial in denominator. So highest power is here 0, 1 and 2. The highest power is 2, therefore its degree is equals to 2. I hope all of you understanding. Let us consider one more example. Now suppose he has given that the polynomial x raised to 4 minus 2x plus 1 and divided by one of the polynomial x square minus 3x plus 5. So observe here, we need to identify whether this rational function is proper or improper. Proper or improper. Now see here, the degree of the polynomial in numerator. So that is what? Px. Degree of what? Px. So highest power of the variable is 4. Therefore its degree is 4. And the degree of the polynomial in denominator, that is what? Qx. So here the highest power is 2, therefore its degree is 2. So observe here, degree of this px is greater than degree of qx. Therefore this is one of the improper rational function. And here the degree of the polynomial px is less than degree of the polynomial qx. Therefore this is one of the proper rational function. I hope all of you understood this entire concept. What is the concept here? Partial fraction method is used to integrate the proper rational functions. And rational functions means the functions of the form px by qx, where qx is not equal to 0 and px and qx both are polynomials. And if the degree of the px is less than degree of qx, such type of rational functions are known as proper rational functions. And in which rational functions degree of px is greater than or equal to degree of qx, such type of rational functions are known as improper rational functions. As you know that the degree of the polynomial means highest power of the variable involved in the polynomial is called as what? Degree of a polynomial. So, and we exercise some of the examples to identify degree of the polynomial and also to identify which of the given rational function is proper or improper. Now, if the function is proper rational function, to integrate it, we have some proper fraction formats or partial fraction formats. So now we need to observe that partial fraction formats. So if the given rational function in that partial fraction format, then only we are going to integrate by using the partial fraction method. Now what? Some important partial fraction formats. Partial fraction formats. In that the first one is px plus q, px plus q divides x minus a into x minus b. So observe here, this is one of the proper rational function. Why? Because degree of the px is 1 and degree of qx, x into x square means highest power of the variable is 2. Hence degree of the px is less than degree of qx. Therefore, this is one of the proper rational function. If the given rational function is in this form, then we can express it as a divided by one of the linear factor x minus a plus, and second one is b divided by another linear factor, that is what? X minus b. So observe here, if the rational function in this proper or partial fraction format, then px plus q divided by x minus a into x minus b can be expressed as a by x minus a plus b divided by x minus b. And observe one more thing here. Here the denominator is linear factors and distinct from one to another, because first one is a x minus a and the second one is a x minus b. Now let us consider the second partial fraction format. Px plus q divides x minus a whole square. If the given rational function in this form, so observe here, this is also one of the proper rational function, because degree of this polynomial in numerator is 1 and as well as degree of the polynomial in denominator a minus b whole square, x square means degree is 2. Therefore degree of the numerator is less than degree of denominator, therefore it is a proper rational function. And observe one more thing here. This, the polynomial in the denominator is one of the linear factor and they are repeated. X minus a whole square means x minus a into x minus a. So here the factors are linear but they are repeated. If the rational function is in this form, then it can be expressed as a divided by x minus a plus b divided by x minus a whole square. I hope all of you are understanding. And there exists one more format, that is what? If the format is px square plus qx plus r divided by x minus a into x minus a into x minus b whole square. Now observe the denominator here. Here there exist linear factors and as well as repeated and non-repeated factors. If the denominator consists linear factors, repeated and as well as non-repeated factors, then this rational function format can be expressed as a divided by one of the factor, a divided by one of the factor, a divided by one of the factor x minus a plus b divided by another factor x minus b plus c divided by square of this factor, that is what, x minus b whole square. I hope all of you are understanding. And the fourth format is, the fourth format is if px square plus qx plus r divided by x minus a into ax square plus bx plus c. Now observe here, this is also one of the proper rational function. Why? Because degree of this px is 2 and degree of the qx, x into x square means x cube, therefore degree of the px is less than degree of qx, therefore this is also one of the proper rational function. If the rational function in this format means, observe the denominator here, linear factor as well as quadratic factor, but this quadratic polynomial must not be further factorizable, must not further factorizable, further factorizable. If the rational function in this format, then that rational function can be expressed as a divided by one of the factor x minus a plus, in denominator there exists a quadratic factor, that is what, ax square plus bx plus c, and in numerator we should take one of the linear polynomial, that is what, already we considered a, then it can be written as bx plus c. So these are the some important partial fraction formats. If the given integral problem consists of proper rational function, and if it is in this format, then we need to express that rational functions in this given orders, then only we are able to integrate that integrand by using what, partial fraction method. So let us consider one of the example to understand the method of solving integral problems by using partial fraction method. So I am going to consider one of the most important problem, which will be asked in your annual examination many times. So let us consider first example. Find or evaluate integration of, let us consider I, integration of x divided by x plus 1 into x plus 2 with respect to x. Now we need to identify this integral value. So first thing you need to observe, the given rational function is proper or improper. Obviously see here, degree of the polynomial in numerator is 1 and in denominator x into x square is x into x is x square, so degree is 2, therefore degree of px is 1, degree of qx is 2, hence it is one of the proper rational function. Now we need to observe the format also. Format, denominator consists two linear factors and they are different, so it is of the form, this one, px plus q divided by x minus a into x minus b, because the denominator consists here linear factors and they are different from each other. So if the rational function in this form, then it can be expressed as a divided by one of the factor plus b divided by other factor. So that's why here I am going to express this rational function, that is what, x divided by x plus 1 into x plus 2 is equals to a divided by one of the factor x plus 1 plus b divided by another factor x plus 2. Let us consider this is your equation K. So after expressing the given rational function in the standard partial fraction format, we need to identify the values of a and b. So to identify the value of a and b, LHS same as it is x divided by x plus 1 into x plus 2 equal to, on RHS I am going to take the LCM here. The LCM of x plus 1 and x plus 2 is x plus 1 into x plus 2, then a is multiplied by x plus 2 plus b is multiplied by x plus 1. Now observe here, on LHS and RHS denominator is same, that's why I am going to cancel from both sides. After cancelling denominator on both sides, we get what? X is equals to a into x plus 2 plus b into x plus 1. Now by using this equation, we need to find the values of a and b. So to find the value of a, we need to make or eliminate this b. So to eliminate b, we need to make the coefficient of b is equals to 0. To make the coefficient of b 0, we need to consider the value of x plus 1 is equals to 0. To identify the value of a, we need to eliminate b. To eliminate b, let us consider the value of this x plus 1. Let x plus 1 is equals to 0. It means the value of x is equals to what? Minus 1. If x is equals to minus 1, then the above equation, this equation, in place of x minus 1 is equals to a into x value minus 1 plus 2 plus b into, observe here the value of x plus 1 is 0, so b into 0. Minus 1 is equals to a into minus 1 plus 2 is 1 plus b into 0 is 0. Therefore, finally we get minus 1 is equals to a into 1 a. Therefore, the value of a is equals to what? Minus 1. We got a now. To identify b, we need to eliminate a. To eliminate a, we need to make the coefficient of a is equal to 0. So for that, we need to take the value of x plus 2 is equals to 0. So what next? Next is let x plus 2 is equals to 0. If x plus 2 equals to 0, the value of x equals to minus 2. If the value of x equals to minus 2, this above equation becomes x value minus 2, which is equals to a into the value of x plus 2 we considered 0 plus b into x value minus 2 plus 1. So minus 2 is equals to a into 0 is 0 plus b into minus 2 plus 1 is minus 1. So finally minus 2 is equals to b into minus 1 minus b. Now minus get cancel on both sides. So finally we get the value of b is equals to what? 2. I hope all of you understood. What is the procedure? First we need to express the given proper rational function in proper or partial fraction format. After that we need to identify the values of a and b. To find a, make coefficient of b 0. To find b, make coefficient of a is 0. After finding the value of this a and b, substitute these two values in equation K. Substitute these two values a and b in the equation K. Now what? Equation K implies. So equation K is on LHS. x divided by x plus 1 into x plus 2 is equals to a divided by x plus 1. The value of a is minus 1. So, minus 1 divided by x plus 1 plus b divided by x plus 2. b is 2. So, 2 divided by x plus 2. I hope all of you understanding. After substituting the values of a and b in k, so next step is we need to take integrate on both sides. What is the next step? Integrating on both sides. Integrating on both sides, it means integration of x divided by x plus 1 into x plus 2 with respect to x is equals to integration of minus 1 divided by x plus 1 dx plus integration of 2 divided by x plus 2 dx. I hope all of you understood. Now see here, just observe the term in left side, that is what integration of x divided by x plus 1 into x plus 2 dx. Is it your I? Is it your I? So observe here. So LHS is equal to what? I. Therefore I is equals to I is equals to. So because we need to find out the value of this integral. So hence I is equals to, so this minus 1 taking outside the integral because it is constant. So next integration of dx divided by x plus 1. Integration of dx divided by x plus 1. Already we know that is what? Log x plus 1. Log x plus 1 plus 2 is a constant taken outside the integral, and then integration of dx divided by x plus 2 is log x plus 2. I hope all of you understanding. Now, after finding the integral values, now observe this term and as well as plus c integral constant. We need to write plus integral constant. Now, observe this second term 2 log x plus 2. So, it can be expressed by using the properties of log. Now, what? Properties of log. So, properties of log. The first property is if n log m is exist, if n log m is exist, n log m, then it can be expressed as log m power n, log m power n. Therefore I can be expressed by using this property of log minus log x plus 1 plus 2 log x plus 2 means log x plus 2 whole square plus integral constant c. I hope all of you understanding. Now let us consider one more property of the log. We know the one more property of log, that is what? If we have log m, if we have log m minus log n, if we have log m minus log n, then it can be expressed as log m divided by n. By using this property of log, I can be expressed as log m minus log n can be expressed as log m, that is x plus 2 whole square divided by n, that is what? X plus 1 plus c integral constant. And this is what? Required integral value of the given problem, integration of x divided by x plus 1 into x plus 2. I hope all of you understood the method of or procedure to find the values of integrals using the partial fraction method.